Alright, let's look at the homework number 6, problem number 2, part A. Alright, so let's use power series method to solve this differential equation. Alright, so y double prime, so which is summation, and it goes from 2 to infinity, right? N times n minus 1 times c sub n. Then we have x to the n minus 2, right? And this has to be equal to 4, right? And then you have a summation, n goes from 0 to infinity, c sub n, x to the n. Alright, so since we want to match the powers, instead of n minus 2, we would like to have n. So what we can do is we can start from n equals 0 instead of n equals 2. So we're going to start from n equals 0 to infinity. So we have to increase the indices by 2. So n becomes n plus 2, and n minus 1 becomes n plus 1, and you have a cn plus 2, right? Then you have x to the n, right? And this is equal to, right? I'm gonna put this 4 inside, so you have a summation. N goes from 0 to infinity, and 4 times cn, x to the n, right? So we need to match the coefficients, so we have to match this guy with that guy right there. So we want to set that equal to each other, right? So by dividing through by quantity n plus 2 times quantity n plus 1, we can solve for, we can isolate c n plus 2, right? So this is equal to 4 over, alright, n plus 2 times n plus 1 and c sub n. Alright, so let's list the odd terms and the even terms. Alright, so we have, let's see, so when let's do the even terms. So when n equals 0, right, so we have c2, right, is equal to, right, so plug in 0 here and 0 here, so it's a 4 over, I'm gonna write 4 as 2 squared, so 2 squared over, right, 2 times 1, so we can write it as a 2 factorial, and then you have a c0, right? So when n equals 2, then we would have c2 plus 2, so c4 is equal to, right, another 2 squared, right? Then you have a 4 times 3, so 4 times 3 and c2, right? Then we can plug this guy, so this is c2 right here, because there's a c2 there, so we would get right, 2 squared, so it's going to be 2 to the 4th power, right? 4 times 3 times 2 factorial is the same thing as 4 factorial, and then c0, right? So we are already seeing the pattern here, so I'm going to just go ahead and say dot dot dot, right? If you want to find the c2n, right, is equal to Alright, so you have, let's see, if it's 4, so it's a 2 to the 2n power over, right, so you have a 2n factorial times C0. Alright, so let's do the odd terms. So n equals 1. Alright, so what we get is n equals 1, so we can get C3 is equal to, right, again 4, I'm going to write it as 2 squared over, and it's going to be 1 plus 2, 3 times 2, so it's going to be a 3 factorial times C0. Right? And then we're going to do n equals 3, and we can find C5 is equal to 2 squared over, so it's going to be 3 plus 2, so 5 times 4, so 5 times 4, and C3, right? And just like before, we can plug this guy in here to get 2 squared times 2 squared, 2 to the 4th. 5 times 4 times 3 factorial is 5 factorial. Then you have a C1. Actually, I messed up somewhere. This is supposed to be right here. That's C1. Alright, sorry about that. So C1. Alright, so what we want to do is actually, instead of writing 2 squared, I'm going to actually, because I want a 2 cubed, so I'm going to write 2 cubed over 3 factorial. Then I'm going to divide by 2, so C1 over 2, right? And same thing here, I'm going to put 2 to the 5th, and over, I'm running out of space, so I'm going to just, can I just do it here? So it's going to be, I want the 5 here, but I'm going to put over 2. Alright, then I'm seeing a pattern, so we have C2n plus 1 can be written as 2 to the 2n plus 1 over quantity, 2n plus 1 factorial. Then constant is C1 over 2. Alright, so now we have a solution. Alright, so therefore we have y is equal to, right, summation, right, summation, right, so C0 is just a constant, so put it in front, right, so n goes from 0 to infinity, right, so you have a 2 to the 2n over 2n factorial x to the 2n, so these are the even power terms, right? Then plus odd power terms, so constant would be C1 over 2, so I'm going to put C1 over 2 pulled out. Then you have a summation, n goes from 0 to infinity, and then you have a 2 to the 2n plus 1 power over 2n plus 1 factorial, right? Then you have x to the 2n plus 1. Alright, then you can see that this is going to be equal to C0, right? You recognize that this is going to be, so it's a 2x to the 2n power, so this is going to be a hyperbolic cosine of 2x, right? Because you have 2 and x there. And plus, right, C1 over 2, right? Then this is going to be a hyperbolic sine, so hyperbolic sine of 2x, right? So that's the solution, right? So that's how they got this solution right there, right? That's it. I hope that this was clear.